in the next 44 minutes or so, what I'd like to do is motivate why I hope that all of you will agree with me that phenotyping is one of the most important things we do and need to be doing in our community, and motivate some of the thinking that's gone on in contributions that have gone on in our community to motivate why we're holding our second annual Phenotype February. And then Azza and Gautam have done a great job of coordinating what the actual activities of the month will be. And so Azza is going to walk through the details of that. So for those who are new to the community, this is the second time we are holding a Phenotype February. Last year, we had this crazy idea of 28 days in the month. Let's do 28 phenotypes, or at least try to engage in a conversation about 28 different clinical ideas. And we learned quite a lot by focusing the community's efforts in the area of phenotyping, both from the clinical aspect of creating phenotypes for diseases that we can actually use in network studies, but probably even more importantly, learning about the methodologic issues of the science of phenotyping. And Azza, in fact, presented at last year's OHDSI Symposium about many of the lessons learned that came out of Phenotype February. Much of that has actually motivated a lot of research and development in phenotyping in our community as a follow-up to that. And since it's a cute little moniker, we figured we'd just run it back and hold Phenotype February again starting tomorrow, with a more deliberate orientation to thinking about how we can, as a community, focus on the area of phenotype development and evaluation. With that in mind, I'm going to just provide a little bit of high-level orientation to why I'm particularly passionate about this area and why I think we need to be working as a community towards the work that we're doing. So as a community, we are using a distributed data network that's predicated on this idea that different data sets in source formats are all standardized to the OMOP common data model so that we can standardize the structure and the content of our data sources. And what that enables us to do is be able to write analysis code that can be distributed to any organization who has an OMOP common data model, generate aggregate summary statistics that can be shared back as open evidence that we can communicate. And we've used this picture, has been published many times in various languages all around the world. And yet, this picture isn't quite as simple as it seems, because while this suggests the idea that if you can standardize the structure of your data, that you can standardize analytics, there's one sneaky little part in between that is the devil in the details that we're going to be focusing the month of February on. And that's just because you have standardized the structure and content of the data does not necessarily mean that you have standardized the clinical ideas that you are representing in your study. And if we can't reach a common shared semantics about what it means to represent exposures and diseases across our network, we're not actually able to produce evidence that can be meaningfully interpreted across our network. Now, that journey to evidence, effectively all of the standardized analytics we apply use cohorts as inputs. So when we conduct treatment pathway analyses, like the results that George published in PNAS several years back, the input to that process was cohorts. When we conduct incidence rate analysis, like the paper that Jing Teng published in BMJ, we require cohorts as inputs. When we conduct comparative cohort designs, like the kinds of large-scale analysis that we published in Legend, that Mark led us through and published in Lancet, that requires cohorts inputs. For running self-controlled case series studies, like the work that Jenny Lane published on safety of hydroxychloroquine, that requires cohorts as inputs. And when we're running patient-level prediction studies, such as our seek cover analysis that Ross published, those require cohorts as inputs. So a cohort, when we are talking about this in OHDSI jargon, is a specification to identify the set of persons that satisfy one or more criteria for a duration of time. And so for all of these different analyses, they require standardized inputs, which are these cohorts. Whether we're talking about the target population, the comparator, or the outcome, we are creating cohorts to represent these patients. And it's actually these input cohorts that serve as the foundation of all of the analyses we conduct as a community. And so while it's great that we standardize the data to the OMOP common data model, and it's great that we have all these standardized analytic packages, if we can't also as a community come together to standardize how we create these cohort definitions and how we actually understand that they are fit for use in our research, then our entire structure of how we're trying to generate reliable evidence falls over. And so it's critically important that as a community, we come together to harden the science of phenotyping and to generate a common set of phenotypes that we can use that allow us to translate the standardized structure and content from the CDM into the inputs that are required for all of our standardized analytics that we might be performing. So in this picture that we're now trying to show is kind of a framework for how to do open science systems to build trustworthy evidence. Phenotypes are very intentionally right in the middle of the heart of this picture, because while it's great that we have a data network and we're starting to make great progress with the work that Claire's been leading on data quality evaluation, and it's great that Martijn showed us all this progress on study diagnostics and the ability for us to know that we've produced unbiased estimates for estimation. Right in the middle of this is phenotype development and evaluation, the notion that given a set of data sources, we can identify the set of patients that we are interested in studying to make sure that they are fit for use and can be appropriately used as the input to our analyses. And if I look across this entire pipeline, I'm really excited and impressed by the progress we've made as a community. And at the same time, if I look at where's our kind of most critical Achilles heel right now, I'd point right to this phenotype development and evaluation cycle. If you've been following the OHDSI forums, you can see active debates about, do we really need to have phenotypes? And do phenotypes, are phenotypes consistent across the data network? And do we have to have lots of different exotic flavors of phenotypes? Is it even appropriate for us to have one phenotype for a common idea? We have no current objective diagnostics that actually allow us to know that a phenotype is fit for use and can be passed forward. And we currently don't have any explicit approach for estimating measurement error and using the measurement error that we produce in order to both determine that a phenotype is fit for use or to calibrate our estimates given the measurement error that has been estimated. So there's a huge amount of work that we need to be doing as a community in this space that in the absence of that work, I think we can only go so far in terms of having reliable real-world evidence. And yet on the flip side, if we can come together to build out our phenotype library and establish the science of phenotyping as a community, it's going to be the biggest accelerant we can have to generating reliable, scalable evidence across our community. So for those that are new to the OHDSI jargon, we try to be precise in defining specific terms that we're using in this phenotype space. So when I use the word cohort, I mean very explicitly a set of persons who satisfy one or more inclusion criteria for a duration of time. And this is a specific definition of the term cohort that's relevant to our implementation of the idea of a phenotype algorithm that George Ripsack and others have published, representing the notion that a phenotype is something that is time varying, basically representing a health state of an individual that can be inferred based on observations that we see across our observational data. So given that a cohort is a set of persons with durations of time, that means that any one record in our cohort table we can refer to as a cohort era, and that represents the continuous period during which a person has satisfied a cohort's inclusion criteria. So you can think about this as a given individual on a given start date for a given duration that would end with an end date. That's the period of time that a person belongs to a cohort. And we want to be able to construct those cohort eras to represent that time-varying disease state that a given individual may have. And so when I use the phrase cohort definition, what I'm talking explicitly about is the specification for how to identify a cohort. Now, we in the community have experts in thinking about rule-based phenotype algorithms, and we've got various tools for that, as well as probabilistic phenotype algorithms. And one of the topics of conversation is how to integrate those different ideas together. But regardless of how you go about constructing a cohort definition, these words still should hold true. We need to think about finding a set of people who satisfy criteria for some duration of time, where time is an essential element of the cohort that we're constructing. The criteria are things that we are observable, and identifying that membership of persons into that cohort is what's going to enable us to conduct all of our standardized analytics. Now, the exciting part is that we made a lot of progress in the community in developing tools. And in fact, even in the last year, we've made even greater progress in various parts. We have tools for phenotype development, as well as tools for phenotype evaluation. And as a community, we're authoring a phenotype library to provide a resource of existing phenotypes that have gone through a process. I want to highlight several of the innovations that are useful and salient, particularly with an eye towards encouraging all of you to participate in Phenotype February. The first tool that is quite actively going to be used as it relates to developing rule-based phenotypes is Atlas. Within Atlas, as a web-based user interface, you can construct concept set expressions representing the list of codes that represent clinical ideas. And one of the latest features that has been pushed into Atlas in version 2.12 and above is the integration of Phoebe, such that we have a tool that actually explicitly recommends concepts when you're going through the concept set expression development process, which is an exciting enhancement that is, at least for my own personal research, is dramatically increased the quality of the concept sets I've created, plus has made it about 10x faster than the process I previously went through. So Anna Ostropolitz and Chris Knoll did a wonderful job with that new feature. And this time permitting, I will try to demo that real quickly so that you guys are aware of it. Perfect. Beyond concept set expressions, we also have cohort definition, the ability to construct cohort definitions. And you've seen various new features come into Atlas as it relates to trying to make that process more and more efficient, including be able to reuse components of a cohort definition. The other feature that's available in Atlas that is relevant to phenotype evaluation is the use of profiles, so that you can actually drill down to an individual patient and look at their data to be able to assess things. So for those who are looking for a web-based interface tool to be able to point and click their way through conducting analysis, Atlas is a great place to start. And in fact, for those who are looking for a possible opportunity to contribute and want to participate, you'd only need to be able to use Atlas as a user interface tool to be able to make meaningful contributions to this month for Phenotype February. For those of you, though, who are interested in understanding programmatic approaches to developing rule-based heuristics, I encourage you to look at the Caper package that Martin is maintaining. And for those of you who are interested in probabilistic phenotyping, Juan Banda continues to push and promote the Aphrodite package. And that's certainly a topic that we're going to want to actively discuss this month as we think about this moving forward. Now, as I talk about phenotype evaluation tools, we have a variety of those available in the community. One of the tools that was released this last year is Cohort Explorer. This is a R-Shiny-based app that allows you to review an individual case. So for those of you who have programmatic access to your data and want to be able to interface with the data through another capability, the Cohort Explorer package is available. You can think of that as roughly analogous to the Profiles tool within Atlas. Our cohort diagnostics package has gone through considerable enhancements over the last year. Jamie Gilbert's done a great job of expanding this to provide a tool that provides quantitative summary of characteristics about a given cohort so that you can start to identify sensitivity and specificity errors, as well as identify hints of index date misspecification. And then last but certainly not least, Phevaluator. Joel Swerdal has continued to advance this technology and has released this tool as a Hades package just last year. And this is a tool specifically to use probabilistic probabilistic modeling to estimate the sensitivity, specificity, and positive predictive value of a given phenotype algorithm. All of these are tools in the OHDSI ecosystem that we encourage you all to take advantage of. And during Phenotype February, we really want to showcase these tools so that those who are not familiar know how to use them and can hopefully apply them yourself in your own data to be able to gain your own insights. The last one I want to highlight is the Phenotype Library. Gautam Rao and Azza Shoiabi have been doing a great job within the Phenotype work group to try to establish a standardized process for our community to be able to submit phenotypes that have been developed, to evaluate those phenotypes, and to ultimately conduct an extensive peer review process such that we can issue phenotypes that can then become reusable elements that the entire community can take advantage of. And we've had some fits and starts over the last several years in trying to get this to a place where we really feel comfortable that as a community, we should all be able to contribute and make use of this package. But what's been exciting over the last year is to see the maturity of the pipeline whereby the Phenotype Library isn't just an open-ended conversation of what we can or can't do, but actually is now manifest as code, which is fully compatible with all of our Hades packages, which means now as a community, if we can establish the content of that library with all of the phenotypes being appropriately developed, evaluated, and reviewed, then these can serve as the inputs to all of our Hades packages, which should greatly accelerate all of your work in conducting studies to generate reliable evidence. And certainly one of the primary goals of this month's Phenotype February should be getting phenotypes to done, meaning complete that process and get those entries into our phenotype library so that everyone across our community can benefit from those resources and take advantage of them. All right. So I want to frame up the problem as I've been recently thinking about it, just to try to motivate why I think this problem is so important and why we need to be able to come together with common best practices to try to tackle this. And I'm going to use this cartoon and orient you just to try to provide a little bit of motivation for this. What we have when we have access to patient-level data in an OMOP CDM is a series of time-stamped observations. Here I'm going to show you a cartoon schematic. Imagine this is one person where we're following them over time from left to right. And I'm showing you that this person has a range of different observations from different data domains in the OMOP Common Data Model, the condition domain, the drug domain, the measurement domain. And I'm showing you a very, very small segment of them. Here in the condition domain, I'm showing you that this person has observations of a type 2 diabetes mellitus code 4 times time-stamped on their record, that they've got some records of hyperlipidemia, that they've got a single record of essential hypertension, that they've got a record of acute myocardial infarction. They also could have records of prescriptions. So they got a range of different prescriptions dispensed of metformin, atorvastatin, of atenolol. And they may have measurements, including values such as hemoglobin A1C measures and total cholesterol measures and systolic blood pressure. And this is the data that we have that we try to conduct all of our analyses on. The problem is that this data in this structure as it is requires you to make a leap of faith to try to infer the health state of an individual from the data. What we want is not the data points, but what we want is actually to understand the longitudinal health status of a given individual. We don't want to say that a person has 4 instances of records of diagnosis codes of type 2 diabetes mellitus. What we want to be able to say is there's a period of time that a person has type 2 diabetes. There's a period of time that a person has hyperlipidemia. There's a period of time that they may have 1 or more episodes of acute myocardial infarction. There can be periods of time that a person is a metformin user. There can be periods of time that a person is of the health state of being obese. All of these are longitudinal health states that are fully compatible with our definition of a cohort, which represents the set of people who satisfy 1 or more criteria for some duration of time. So when we go from what we have to what we want, that exercise of inferring the health state from the data is the task of phenotyping. The challenge that we have when we try to go from what we have to what we want is that this is not always a clean and consistent and correct representation of truth. Instead, when we go through that process of creating phenotypes, there are potential errors that can occur. So say, for example, in this particular example, I wanted, and I'm going to back up so you can see it on this screen. I have the data that we have, and I want to infer the state of this person and whether or not they have diabetes and when. Well, I could, as many people in our community have in many, many, many studies, say, I'll just look for the diagnosis codes. And I can see that first time that I see a diagnosis code of type 2 diabetes, I can follow it forward and I can assume that a person with type 2 diabetes is going to have type 2 diabetes for the rest of their lives. So I can just follow that forward. There's a particular challenge with that I'll highlight that explicitly is this term index state misspecification. That is, if my phenotype is based on following forward from a diagnosis code, then I may be incorrect in my assignment of a person's time when they really had type 2 diabetes. Because we can see in the original data here that prior to that first diagnosis of diabetes, we saw that they were exposed to metformin, a drug used for diabetes, and they already had a hemoglobin A1C of 8.2%, which would satisfy our clinical definition. So if our phenotype didn't take into account all the rich information that was available, we may be subject to index state misspecification. Another problem we can run into is a sensitivity, a specificity error. That is to say, we may infer that a person has a disease on the basis of something that we observe in the data. In this particular case, I've shown you this person has a diagnosis of essential hypertension. And so it may be reasonable for a phenotype, as we have used in many studies in the past, to assume that a person who's got a code of hypertension must have hypertension. However, it's also possible that just because we see one diagnosis of hypertension doesn't mean that that reflects the true disease status. After all, we can also see in this person that they're not exposed to lisinopril or a hypertensive drug, and we can see that their systolic blood pressure has actually stayed steady well below the clinical definition of hypertension. And so we can end up in a situation that if we were to infer the phenotype of hypertension based on a given diagnosis, that we may actually have some false positives. That is, infer a person has a disease when it doesn't truly exist. We can also have sensitivity errors. That is, falsely say that a person does not belong to a cohort definition when they actually should. This can happen for a wide array of reasons. In this particular case, I want to highlight specifically the challenge of unobserved information. It may be the case that a person has, what we observe is that the data set does not have body mass index, but of course every person really does have a height and weight. And if you had that information, you might be able to infer someone's status of obesity. If you didn't have that information, it may not be possible. But even if you did have that data in your data set, the only way you could infer obesity status would be if your phenotype itself explicitly went and looked for the values of BMI. Else, if you just focused on a diagnosis code of obesity, as we have done in previous studies, you would actually be subject to misclassifying people who are obese and classifying them as not in that particular health state. So the challenge that we have as a community is that we have tons of data. We have the world's largest health data network. And what we want is to represent people in terms of their health states. And the only mechanism to go from the data to the inference is through phenotypes. And yet all of our phenotypes are subject, all of our phenotypes are subject to these types of errors: sensitivity error, specificity error, and index state misclassification. So when we talk about evaluating phenotypes, the objective that I would assert that is our goal is to try to estimate the extent to which that inference from the phenotype algorithm is consistent with the true health state of patients. We'd like to be able to measure measurement error. That is, we'd like to be able to say, how often do we see sensitivity errors? How often do we see specificity errors? How often do we see index state misspecification? And if we can quantify those numbers, then for the first time, we can actually define what it means for a phenotype to be fit for use. Explicitly, a phenotype is fit for use if the measurement error of the phenotype in a database is sufficiently small that it's not going to negatively impact the interpretation of your analysis results. If you don't have measurement error, you can't determine that a phenotype is fit for use. And yet currently in our community, across almost all the studies we do, we don't know the true operating characteristics of our phenotypes, and we just hope that they're not causing us bias in our interpretation of results. And I think as a community, we can do a hell of a lot better than that. So one thing to keep in mind is that we talk about phenotype development and phenotype evaluation, but we needn't think about those as two different activities, nor do we need to think of them as a two-stage activity. Rather, I would assert that we should be able to develop phenotypes by keeping the goal of evaluation in mind at every step of the way. For example, if we are trying to identify a set of people who satisfy one or more criteria for a duration of time, because that's our definition of a cohort, then we can start by trying to identify the persons who might have the disease. Explicitly, when I say that, I'm saying the aim that we're going after is to try to increase sensitivity, try to reduce that chance that we're missing people who might have the disease. In which case, our task is to create inclusive concept sets that are used in cohort entry events if we're doing rule-based phenotyping. And after you've increased sensitivity, there's the real possibility that now that you've identified people who might have the disease, you might also have identified people who might not have the disease. In which case, a second step of that process can be to restrict persons who likely do not have the disease. And explicitly here, after you've increased sensitivity, your aim can be to increase specificity, or think about improving the positive predictive value of your algorithm. In which case, explicitly, your task is to create inclusion criteria that are going to remove entry events from your cohort for those people that you don't want. And after you've identified the people who might have the disease and removed the people who might not have the disease, then you can think about determining when did the events occur. And that's about determining the start and the end date of each disease episode. And here, our goal when going through that process is to reduce our index date misspecification. So here, if we're developing a rule-based heuristic, this is about setting the exit strategy for our events. It's about refining the entry events and the inclusion criteria to really try to drill down on the specific calendar time that represents that duration of time that you're in a cohort. If we can follow these processes of developing phenotypes with evaluation in mind, we can be in a good position to then use our tools for evaluation to see how good of a job we've done at these tasks. And with that information of measurement error in hand, we can finally start to answer the question whether or not our phenotypes are really fit for use for whatever analytic question that we've got. So I'm going to actually skip that. I want to actually transition this over to Azza and Gautam. Azza is going to walk through how we are thinking about Phenotype February and how specifically you all can get engaged. After Azza goes through this, I'm going to go back to that polleverywhere.com/PatrickRyan800 so we can see what you all want to accomplish and what we can do together.
Whew, let's take a deep breath. It's always hard to talk after Patrick. Okay, everybody, are we ready for tomorrow? Phenotype February. So last year, we aimed for 28 days, 28 phenotypes. This year, our title gonna be 4 weeks, 4 debates, 10 completed phenotypes. We are successful at the end of February if we had completed 10 phenotypes that have gone through a process that we, as a community, feel good about and can reuse, and that manifest in their presence in the phenotype library. And if we have come to a clearer place about few topics that we continuously tend to discuss on the forum across few people. If we open that discussion and have more insights from more engagement, more people, I would think we would be more successful. So the way we have framed it, if you look at the screen, you see this nice triangle, but you can think of the phenotype development and evaluation as we have kind of fleshed out in last year's Phenotype February as 5 steps. They're not linear steps, but for simplicity, let's think of them as starting with the describe of a clinical description of a clinical idea, develop a phenotype having the evaluation in mind, execute that phenotype definition or algorithm across a network of data, then evaluate those phenotype definition using maybe one or two or more of the OHDSI tools, that cohort diagnostics, phe evaluator, or cohort explorer. And then having the last step, which include an independent scientific person or a researcher go through the phenotype and the material and peer review it and recommend or not recommend that phenotype. So you can think of them or of those 5 different steps. Now, we have discovered last year that if we want to really accomplish all those 5 steps, it is time consuming, and it takes time to go through the full steps, and definitely takes more than 1 day. So how can we go through all the steps and complete 28 phenotypes for 28 days? So what we are trying to do this year is to kind of break down the process and use what we have already accomplished in prior years in the community by only work on 10 phenotypes and take phenotypes that have went through the process and yet didn't yet finish it to complete it. So in the first week, we're going to focus on 4 phenotypes only, and those are going to be phenotypes that already have a clinical description, have been developed and executed on more than 1 database, already have an evaluation material that's cohort diagnostics and phe evaluated results, and OHDSI collaborator have already went through this data, interpreted, and kind of wrote a brief summary of what they think of the phenotype definition and recommend it already to the library. And all what we need for that week, for each day, for a peer reviewer to go through this material and either recommend that phenotype definition for the library or provide maybe modification or reject it because they think the measurement error is too big to be considered for any research. So this is our task for the first week. 4 phenotypes that would go only through a peer review, through a volunteer from the community. In the second week, we will only work on 3 phenotypes. The task will be the last 2 steps. So those are going to be phenotypes that have a clinical description, have been developed and executed across databases, also have cohort diagnostics and phe evaluated results ready, but we need an independent researcher to go over this material, interpret the data present in cohort diagnostic and phe evaluated, and maybe cohort explorer or any other method for evaluation, and digest this data and write a summary of what they think of that phenotype or modify it. Then we need another independent peer reviewer to go through this and either reject, accept, or recommend changes. So that would be 3 phenotypes for the week number 2. In week number 3, we're going to only work on 2 phenotypes. And in that week, we will work on phenotypes that only have a clinical description, have been developed, or somebody developed an algorithm to target that clinical description, but nobody executed them on their databases. We don't have phe evaluator or cohort diagnostics result. So the task will be to run maybe a network study where we can run cohort diagnostic, run phe evaluator for those 2 cohort definitions and go through an evaluation and peer review. And in the last week, we're going to work on 1 phenotype completely from scratch, has nothing yet, and we as a community can rally behind to get to complete. So this is the overall design. In addition, in every week, we're going to open the forum for specific debates or discussions related to that week. So in week 1, we're going to discuss things related to the peer review. In week 2, we're going to discuss things related to the evaluation. In week number 3, we're going to talk about our tools and how can people really truly execute those tools and how much we can understand diagnostics. And in week number 4, we're going to focus on the coupling, rule-based and probabilistic approach for phenotyping. So how does that mean for the calendar? So we have week number 1. We have already excited, and we're very grateful for amazing collaborators who already raised their hand to cover us for week 1 and do a peer review for those existing phenotypes that are already ran across a network of data. And we have results, and they have been evaluated by another OHDSI collaborators. And we have Evan Minty, Andrea Newell, and I'll talk about what we're going to do on Friday, and Anna, who are already going to be our peer reviewer for those 4 clinical ideas that you see on the calendar. For week 2, we are opening up for volunteers, and we're really requesting today. We have a list of cohort definition that we're gonna look at the end at the last slide. But the idea here, those are definitions that have been developed, have been executed, and we have evaluation results from cohort diagnostics and from Phe evaluator that we need an independent researcher to look at them, evaluate them, modify the definition, and then a peer reviewer to do the peer review process. And for that, we need those 3. For week number 3, Dr. Alan Wu and his group have volunteered. We're very grateful to work on Parkinson's and Parkinsonism disease. They already, that work has started last year in Phenotype February. We have defined the clinical idea and started proposing some cohort definitions, but we're going to go through the process. And here we need volunteers to run cohort diagnostics on their data for the proposed definitions that are going to come out of this work, and work with us to interpret what we observe across the OHDSI network. We are open for another phenotype that we can do the same work for. This can really be any idea, any core definition or phenotype that somebody has already in mind that need to be evaluated across the network. And then in the last week, we are very grateful for Dr. Aziz Kaiser, who and his group has proposed to work on neonatal hypoxic ischemic encephalopathy. And they want to take it from scratch and have the communities to support them to complete that work completely. So we here are open for 4 different clinical ideas that we can help have the community behind to help. In addition, every Friday on the Phenotype Core group, we're going to open every Friday a call where we're going to go support the community need depending on where they are. So for example, for the first week, we're going to do a peer review that is public. You can join the call, and I'm going to be only facilitating, but we're going to all do a peer review in a collaborative fashion to see what we can learn and if what we know about appendicitis, looking at the material that already exists. And I talked about the debates or the discussions. So in the first week, we're going to open the forum on discussing what do we mean by peer review and how we can read it through that. And we really need inputs from people who maybe have done this before or are familiar with other societies or groups that do a peer review for phenotypes. In the second week, we're going to focus on the evaluation topic. And here we're going to hold a debate on the forum that really talk about what do we mean by evaluation or validation, and our tool truly sufficient to achieve what Patrick talked about, about assessing the measurement error, or we really need to always bounce back to the conventional way of adjudication or chart review adjudication to assess that measurement error. And there's pros and cons, and we want to open that on the second week to discuss. In the third week, we're going to talk about development. And here we're going to talk about what do we mean by cohort development. And there's a debate in the community. Do we need to do customized cohorts depending on the fit for use or depending on the analytical case and the database? And in that case, why do we need a library? Or what do we mean by modeling the clinical idea irrespective of the study? So that's another debate that we're going to open. And lastly, in the last week, we're going to talk about probabilistic model and what innovations we have currently in the community to couple probabilistic phenotyping with rule-based phenotyping to push the science work forward. So that is how we are trying to think of how we want to plan Phenotype February this year. This is a list of cohorts or phenotype definitions that have been worked in the community mostly from last year, Phenotype February, and they have reached a stage where they're not yet done. So those can be things that we can work on in those spots if you have volunteers who are interested in any of these phenotypes. So if you're interested in any of those, please raise your hand and you're ready to contribute and work with us. We're actually not interested in people who have done any evaluation in the past. We're interested in new collaborators who really want to know how we can do this. And so we can achieve our goal of increase our collaboration around phenotype evaluation and development. So don't be worried about that you have not done this. Even if you don't have access to OMOP data model or anything, we will work together as long as you have the interest in working on any of these ideas. And that.
Cool. Thank you, Azza. So I'm going to just pull up our poll everywhere so we can see what stuff everybody wants to be doing. So things that you all said that you'd like to see accomplished in Phenotype February. We want to see some comparisons with non-OHDSI phenotypes. Lots of you want to see phenotypes actually get done. Phenotypes with sophisticated logic, not just a code in a code set. Looking at differences in phenotype definitions across data partners. Demonstration of the utility of our diagnostics. Participation from new members. A step-by-step approach for newbies. And this discussion of what is a phenotype and how to use different sources, detailed walkthroughs and demos, subject matter expertise. I'm gonna actually extract all of this stuff and post it on the forum, but I think for at least all those top things, I think that's explicitly what we really have in mind for what we're going to try to accomplish as a community, and want to make sure that we hit on all of these points. And I think the plan that Azza's laid out very much should try to accomplish that goal. Before we turn it over to Danny to provide a comment about ISPI, let me just open it up to see if anybody has any questions or comments about plans on this, our Phenotype February Eve, and what we've got planned for the fun in store for the next 28 days.
So I see there are several hands up, Daniel, Mirza, Lax, but I'm not sure if those were hands up for when Azza asked for people to raise their hands versus actual questions. So if anybody has a question, I think you could probably just unmute and ask it.
All right. Well, hearing no questions, we'll hope that that was sufficiently clear and not just overwhelming.
Great, we have one.
Sorry, so I do
there
have
we
a
go.
question.
Yeah, go ahead.
So
Sorry
how-
for jumping on late.
Yeah.
Go
sorry,
ahead, sorry.
So how do I volunteer, and what do I do if I want to take part?
Perfect question. I was gonna say this before you even asked. Okay, so most of all the action that gonna happen gonna be in the phenotype development and evaluation work group. So it's the work group that you can reach from the website and on Teams. You can just get into the channel and post in there. If you couldn't find the channel for any reason, or you're struggling with Team, or you couldn't reach the work group, you can email Gautam. Maybe you can put your email in there. You can email Gautam on his OHDSI email, and we're definitely gonna reach out for you to see how we can work. But if you really don't know anything how to get there, get to Patrick. He will get you to us if worse comes to worse. But Patrick, Gautam, myself, Evan, Menti, Craig, Jules, we have any people who you know are active in phenotyping are active members of the work group, and they will get you to the right place.
Okay,
But the
excellent.
right
So the communication is going
forum
to be.
is the. Sorry.
I was just going to say, so Teams, the Teams channel is going to be
Yes.
the main communication. Okay.
Yes,
And if
that's
you're
where we're
not
gonna be.
in the if you're not in the phenotype team, I just put the link in to it's a basic form to join any work group, not just phenotype, but specifically if you want to join the phenotype work group, just fill in that link. If you don't have the chat, go to the work groups page on odyssey.org. It's right at the top. And there's a link there for join our work groups. Just fill it in and we'll get you there really quick.
And Gautam post the forum post that we kicked off the month, and then people can also answer on the post on the forum.
And we'll have all this on the community calls page as well.